Hey there, eighth graders. Today we are going to learn more about a particular math word that you've seen and heard throughout some of our notes, but it's never officially been defined for you. That word is linear. It looks like the word line, L-I-N-E, with an A-R at the end. In fact, some students see it and go, line-R? The word is linear. Go ahead, give it a try, say it, linear. Okay, so you need page 67. And the first thing I'm going to ask you to do before I even go through anything with you on this is I'm going to ask you to look at each of these patterns. So here's what we have on page 67. You've got number 1, and it says stage 1, and then there's like some blocks, some tiles, whatever you want to call them. And then there's a stage 4, and that stage 4 is blank. Okay? And then notice this one, number 2, stage 1, stage 2, stage 3. I want you to focus on the gray tiles for this one. Once again, stage 4 is blank. And then number 3, stage 1, stage 2, stage 3, and stage 4, and this time stage 5 is blank. Number 4 says stage 1, stage 2, stage 3, and stage 4 is blank. And you get to ignore number 5 completely for right now. What I need you to do first, just this thing first, is I need you to pause me and draw, based on the pattern you see here, what should stage 4 look like? Draw it. What should stage 4 look like on this one? Draw it. Focus on the gray tiles. What should stage 5 look like? Draw it. And on this one, what should stage 4 look like? Pause me right now and draw the next stage. All right, did you correctly draw the next stage? And did you draw it as beautifully as I did? This one's actually hard for me to notice when it's not gray. So I'm just gonna shade these real quick. But take a look and see if you followed the pattern and saw what was happening, okay? And the other thing I want you to think through is, how did you know how to draw the next stage? What kind of clues were you looking for? What kinds of things did you notice about what was going on with these growth patterns that allowed you to say, okay, if this is stage 1 and this is stage 2 and this is stage 3, what's going on with stage 4? Let's take a look at the rest of these. Or sometimes a weird one to see and a weird one to draw. And you're welcome to, if you were like, oh, I didn't know how to draw that next one, or I got that wrong, feel free to pause the video and fix any of your drawings. The next thing I want you to do though, still ignoring number 5, the next question I have for you, and this is really the big key question here. You're looking at these patterns. I want to know now, do you think that this pattern is linear? It asks for a justification. Right now, to start though, I just want you to write yes or no on this little line right here. Looking over this pattern, do you think it's linear? Yes or no? Go ahead, write it down right now. Number 2, check out this pattern. Do you think it's linear? Yes or no? Go ahead, write it down right there. Check out this pattern. Yes or no? Do you think it's linear? Go ahead, write it down right there. And last one, check out this pattern. Do you think it's linear? Yes or no? Have you done it? Pause me if you still need a little bit more time. Okay, and the next thing I'm going to do is I am going to say something to you that might surprise you, okay? I am going to tell you that out of these 4 patterns here, only one is linear. Only one is linear. Does that surprise you? Did you write yes more than once? So what we need to do, and here's something very common that happens when I give this task to students and I ask them, do you think it's linear? Very, very regularly, students write, well, yes, 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 yes. I get students that write yes on all of them because they see patterns. And because we haven't really defined this word yet and we're not really clear what it means, which is kind of the whole point of this. But the first thing I want to make really clear to you and make sure that you understand is just because there is a pattern doesn't mean it's specifically a linear pattern. So the first thing you need to get out of this and understand is that linear means something very specific. Not just any old pattern is linear. It's got to be a specific type of pattern. So now that you know only one of these is actually linear, let's see if we can find the one that's linear and figure out why. So one last thing I want you to do, now that you know that there's only one, you can come over here to the column over here on the side, and you can just put a star next to your guess of which one. Now that you know, Miss McGowan told me there's only one, which one do you think is the linear one? Put a star by it. Just for fun, give it a guess. It doesn't matter if you're wrong. Okay, but put it down. Which one do you think is linear? Now, let's actually go through and talk about these patterns one at a time. Okay, so if we look at number one, if I asked you to explain to me what's going on with this particular pattern, there's a lot of different responses that I get from students. I get a lot of students that say, I start with this one block, and then some students see it in different ways. Some students see it as that block was raised up, and then 2 blocks were added below it, and then those blocks were raised up, and 3 blocks were added to the next row, and then that block was raised up, and 4 were added to the next row. And that makes a lot of sense to me. That's what I see. When I first looked at this pattern, I saw it as here's a block, and then they added blocks on each diagonal. They added a block on this side and blocks on that side so that they got kind of this, and I can show you what I'm talking about. They added these blocks here on this diagonal, and then the next stage added 3 blocks on the next diagonal. So on the next stage, I added 4 blocks on the next diagonal. There's a definite pattern there, right? A definite pattern. But I'm going to tell you right now that this answer is one of the no's. So if you put a star next to that one, darn it, you guessed the wrong one. The more important thing though is why. Why does this not count as a linear pattern? Well, let's investigate it. Is this pattern growing over time? But if you look at those diagonals, either you focused on those diagonals, or even if you focused on the rows that they added, this one didn't have any in this row, then this one added 2, and then this one added 3, and then this one added 4. Are we starting to see why that might not be a linear pattern? There's definitely a pattern here, but is it a consistent pattern? As we move from stage to stage, is it adding on the same number of blocks? As I go from here to here, I see that they have added 2 more blocks. Whether I look at it this pink way or I look at it that green way, they've added 2 more blocks to my picture. When I move from here to here, they added 3 blocks. And when I move from here to here, they added 4 blocks. That right there is precisely why this pattern is not linear. The justification here is that the change is not constant. Okay, meaning they added something different every time. They did not keep a constant change. Okay, they added something different every time. So now that I've told you a little bit more on that, let's say you picked one of these 3. Do you want to change where your star is? You still know only one of them is linear. Do you want to change it and adjust it right now? Change your guess? Let's take a look at this one with the gray blocks. What did you see here? If I were to ask you, how did you know how to draw stage 4? And again, people look at this one a different way. When I ask students that, they tell me different things. Some of them say, I noticed that there was this extra piece added. Some of them see it as kind of like those 2 gray sides are like moving out one every time. And so these were my original 6 blocks. And then we moved them apart and added these guys, right? And then I'm going to draw these in pink here. These were the ones that were there from stage 2. And then we added these also for stage 3. And then these were the ones that were still there from stage 3. And I added these for stage 4. So my question is, do you think this pattern is linear? Guess what? This is the only one with an answer of yes, which of course gives away that these two are also no, because I already told you that there was only one that's yes. We can go ahead and write that right now. But really, as always, your justification is more important. Anybody can guess it's 50-50, yes or no. The justification of why is really the more important thing. So why is this the only one that is linear? Let's check it out. As I drew and started showing what's changing here, as I go from this stage to this stage, we added 2 gray blocks. Is that also what happened from this stage to this stage? Why, yes, that's precisely what happened. From this stage to this stage, we also added another 2 blocks. And from this stage to this stage, we added another 2 blocks. Sometimes students find it even easier if they start to write down what the total number of blocks were in each stage. Like this is 1, 2, 3, 4, 5, 6 blocks. 1, 2, 3, 4, 5, 6, 7, 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. And this one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. Sometimes if you write down the total number of blocks, you can see very clearly what's going on here. Is this particular change constant? And sometimes I'm going to word it a different way for you. Sometimes we say it's a constant adding pattern. But we're really talking about the change. How is it changing? That's what's really important with a linear pattern is that change, however it's changing, it needs to be constant. Now, the reason we need to clarify that is because then some students tell me, but wait, Ms. McGowan, number 3 definitely has a constant change. Do we see why? What if I write down the total number of blocks here? Stage 1 has 2. Stage 2 has 4. Stage 3 has 8. Stage 4 has 16, and this one was pretty annoying to draw because it had 32. So a lot of students look at that and they go, that is a constant change, Ms. McGowan. And you know what? You are not wrong, okay? But this is going to be a very important distinction between these linear functions that we're learning about right now and another really important function that you're not going to learn about until 9th grade. But what is different about this change compared to this change? And you'll see why I added this important word right here. As linear functions are changing, it needs to be a constant addition pattern. This has a constant multiplication pattern, which, yeah, that's absolutely a pattern, and it's an important one. Okay, it's something you'll learn a lot about how to work with next year. But linear is supposed to be addition. So we're going to clarify that. It's not addition. Okay, and we'll clarify this and work on this with lots more patterns as we move forward. But if you see a multiplication pattern like that, it's a very important function. It's just not a linear one. It is not a linear one. It does not fit in the linear category. There's a pattern there, yes, not a linear pattern. Okay, now this one, can we all verify now for sure that this one is not linear? If we go through, let's use the skills that we've learned. Let's look at how many blocks there actually are. We actually changed as we moved from stage 2 to stage 3 to stage 4. Notice we not only changed the height of these middle pieces, we had these 2 extras on the side the whole time. So these 2 pink guys on the side stuck around the whole time, right? They were just always there. But the actual height of this went up by 1, and so did the width. So where this was, so this started off as 1 by 3, and then it became 4 by 2, and then it became 5 by 3, and then this one became 6 by 4. Do you think that's going to lead to a constant adding pattern? Well, let's see how many blocks that actually is. This one was 1, 2, 3, 4, 5. This one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We already said this was going to be, this is 5 by 3, which is 15, and then add those 2, which is 17. And then this is 1, 2, 3, 4, 5, 6 by 4, 24, 25, 26, 27. Does that look like a constant rate of change to you? This one adds 5. This one adds 7. And this one adds 10. That's not working out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 26. 24 plus 2 is 26. How could you guys even let me do that? That actually adds 9. And the reason I could recognize that is because I am familiar with other patterns that are not linear, but right now for your 8th grade brain, you need to understand only this is not linear. You don't need to know what it's called yet, but you need to recognize that it's not linear because there is no constant, we're going to use other language here, there is no constant rate of change. It adds something different every time. That's not linear. Okay, the last thing you need to do on this page, and you can pause me if you need more time, but you need to now try to make up your own pattern that is not linear. We're not quite done. We're going to flip the page over and work through the other side so you can really clearly see linear versus non-linear. But right now, pause me if you need a second and draw your own pattern. Do at least 3 stages. You can do more than that if you want, but make up a pattern that is not linear. So the question is, how are you going to do that? Well, I'll help you answer these before you even draw it. How are you going to know? How are you going to make sure your pattern is not linear? You're going to make sure that there is no constant change, which means you're going to make sure you do no adding pattern. So you just need to make up something that you know is definitely not linear because it doesn't have either of those 2 things. Pause me right now and draw that. Okay, did you draw it? I'll check that in your binder checks when we take a picture of that. But just to make sure we really get this idea of linear versus not linear, sometimes it becomes a lot more clear if we do a couple of examples. Okay, so let's start with consider the area of a square as a function of the side length. Function of, that means side length is input, and it shows you that right here in the table. Input is side length and output is area. If the side length is 1, the area is 1. 1 times 1 is 1. If the side length is 2, the area is 4. 2 times 2 is 4. If the side length is 3, the area is 9. If the side length is 4, 16, 25, remember those are perfect squares. We've learned those before. What's the dependent variable? Well, remember dependent means output or y's. The dependent variable was the area and the independent variable was the side length. Just to review that language, that all still exists here because if it's linear, it's a function. There's lots of other types, but that means on my x-axis, I'm going to put side length. And on my y-axis, I'm going to put area. Okay. And then I'm going to plot those points. Side length of 1, notice they put a scale of 2 over here. So side length of 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25. Could we graph another one? 6 would be 36, even though that's not on my table, I know it. And 7 would be 49. I'm out of room. Let me ask this though. There's my graph right there. Is this relationship a function? Is it a function? Yes, it is. How do you know? It passes the vertical line test. So I want to make it very clear that this relationship is a function. It is a function. Is it a function? Yes, it is. Next question though, is this relationship linear? Look at that graph. Do you think it's linear? It's a function. Is it linear? Well, that word linear suggests exactly what you think it does. Is this relationship linear? No. It's not a straight line. But also, the straight line absolutely goes along with the constant rate of change. If you check in the table up here, watch this. It's like the blocks. This goes up 3, and then this goes up 5, and then this goes up 7, and then this goes up 9. That is not a constant rate of change. So just to clarify, this graph is a function, but it is not a linear function. So I want you to understand that function is this big, broad category with lots of stuff in it, and linear is a more specific kind. And we're trying to make sure we clarify, can we recognize that more specific kind? So once again, is this a function? Yes, it is. Is it linear? No, it's not. And I'll help you write an equation. A equals S squared. The area is equal to the side length squared. All right, last one. You ready? Let's finish this page up and make a comparison. What if instead of the area, we make it perimeter? Remember, perimeter is the distance around, and the deal with the square is that they're all four the same. So how many sides does the square have? 4. So if the side length is 1, the perimeter is 4. Okay. What about if the side length is 2? If the side length is 2, 2, 4, 6, 8. If the side length is 3, 3, 6, 9, 12. I'm just adding up the 4 sides because that's what perimeter is, right? So this would be 16, this would be 20. Dependent variable this time is the perimeter of the square. Independent is still the side length. So on my graph, I'm going to put side length down here. And I'm going to put perimeter over here. And I'm going to graph it, and let's see what happens. 1, 4, 2, 8, 3, 12, 4, 16, 5, 20, and I can keep going. I can see the pattern really clearly because guess what? Is this a function? Yes. This also passes the vertical line test. So it's absolutely a function. Vertical line test. Is this one linear? Yes. Not only does the graph make a straight line, so the graph is a straight line. Not only is the graph a straight line, but when I look up here in the table, do you see the constant rate of change? Up 4, up 4, up 4, up 4. So functions, both of them are functions, but only one of them is linear. Okay, write an equation. The perimeter is 4 times s. All right. This is what we're practicing for the next little while. Is it linear or not? If you have any questions about any of this, please ask your math teacher.